What's up, what's up? I am making a, what is that? Smiley face, because you made it to 1.2. Let's get started, shall we? Alright, so in chapter 1, lesson 2, we're describing relationships in tables. And if you remember last time, we used something handy dandy called a table of values. And from there, we were able to plug in the numbers that were in the question, and we were able to see a pattern. And the reason that we use a table of values is so that we don't have to think about or use scratch paper to find all the numbers. It organizes all of our work. So let's find out what our goal is. Here's our goal. It is to describe how the numbers in one column of a table of values relate to the number in the other column. And this is going to be more of a review because we sort of touched up on this in lesson 1.1. All right, so here's our question. Let's move this up. Our question is this. A dance group created, dancing. A dance group created a dance to go with a song that has 10 parts. There will be 2 dancers in part 1. For each new part, 3 more dancers will join. All right, so if we didn't get the question, a great strategy is to read it again. We always have, every word problem will always have an intro. So the first sentence will be an intro. The last part will usually be the question, but our question is going to be here. The middle section will always have our information. So if we know that the intro says, a dance group created a dance to go with a song that has 10 parts. All right, that's our first piece of information. There's 10 parts. Let me just circle the information so you can see. So there's 10 parts, all right? There will be 2 dancers in part 1. And for each new part, there's going to be 3 more dancers. Our question is, how many dancers will be on stage by the end of part 10? We're going to be seeing 2 strategies done by a student named Daniel on the left and Mai on the right. Daniel uses something called manipulative. So he uses cubes to figure out what the answer is, and then he also does a table of values, and then Mai goes straight to the table of values. Depending on what you are most comfortable with, especially in patterns, you can use manipulatives. Even through whatever concept we do in math, manipulatives are always great. Let's see what Daniel is using for manipulatives. He uses these linking cubes. Let's see if I can just straighten out this picture. There we go. So Daniel's rule. This is what Daniel says. I'll use 2 yellow cubes to show 2 starting dancers. Okay, so imagine those are dancers, the yellow cubes that are right here. Okay, say that this is Mr. Mike and Mr. Nicanor. See? The dynamic duos. Actually, no. How about Mr. Lee and Mr. Nicanor? There we go. Mr. Lee, Mr. Nicanor. Just because we're twinsies. Yeah, right? Okay. I'll add 3 red cubes to show each group of dancers that joins in. So after part 1, Mr. Lee and Mr. Nicanor are joined by, so Mr. Lee and Mr. Nicanor are here, and we're also in part 2 and part 3 and part 4. Remember, we're trying to find out 10 parts. Okay? We're going to add 3 new teachers. Let's say that this is Mr. J, Miss M, because she's a great dancer, and then we'll make this Mr. Mike. So the 3 of them. Regardless of who that we put on here, just know that we're adding 3, like this. We're adding 3 cubes every part. So part 3, we're going to add 3 more, and so on and so forth. And what Daniel says, I'll use my model to start a table of values. I can write a pattern rule to figure out the number of dancers. And he writes a table of values on your next page. So if you go to the next page, he writes it right here. It's actually really cool. Nice and organized. He used ruler lines, and which is something I always want you to do. He's labeled column 1 part, and then number 2, number of dancers, and he also put a title, our dance, which is very important. Title and columns and values. All right. There are 2 dancers in part 1 that we know, right here. 2 dancers in part 1. For part 2, let's look over here. I add 1 group of dancers, 1 group of 3 dancers. So you're adding 3 dancers. If we look, let me move this closer, just like this. Make that bigger. Okay, so I'm going to touch base back and forth. Maybe I'll use a pen this time. Let's use red. All right, so here's part 2 right here. And part 2 is also right here. So he uses it as his table of values. And then he does part 3, which he puts right there. And lastly, let's use yellow. He does part 4, which he does right there. As you can see, he uses his manipulatives, which are located on the left, to fill out his table of values. And if this is something that you're comfortable with, using manipulatives and then doing this, even if you wanted to get a scratch paper and start drawing them out so that you can have sort of a pictorial representation, that's a great strategy as well. All right, so let's clear all this stuff. Oops. Didn't want to do that. Let's clear there. Okay. Now, if we continue to read on, here's my pattern rule. The number of groups, for part 2, add 1 group of 3 dancers, so that's 5. For part 3, add 2 groups. So 2 plus 3 plus 3 equals 8. Here's my pattern rule. This is the rule that Daniel came up with in terms of relating for the pattern. The number of groups of 3 that I need to add to the starting number is always 1 less than the part number. Huh. What does he mean by that? Let's say that again. The number of groups of 3 that I need to add to the starting number is always 1 less than the part number. Let's see if that's true. You can see from the table of values, let's skip this, that it is true. Because every time that you're adding 3, so 1 group, you're multiplying by 3, you're continuing to add 3, right? But it's always going to be 1 less than the number. So 2 times 3 is 6, minus 1 is 5. And because of this, I know it might confuse you without seeing the manipulatives, which are right here. You're always multiplying by 3. So the second part, you multiply this by 2 times 3, which would be 6. It's always going to be 1 less. 3 times 3 would be 9, but it's going to be 1 less. 1, 2, 3, 4, 5, 6, 7, 8. So instead of 9, there's 8, which is 1 less. If you're confused by that, check out what Mai's rule is, because she explains it right from the get-go. The number of dancers increased by 3 each time, so you're multiplying it by 3. If there were 3 dancers in part 1, the number of dancers would always be 3 times the part number. So the part number is right here. That's the part number. You see in her table of values, she's multiplied everything by 3. Interesting. I made a column in my table showing multiplying by 3. I noticed that the number of dancers is always 1 less than 3 times the part number, which is what Daniel was talking about in that last little bit. So it's 1 less than the part number times 3. So her pattern rule is this. Multiply the part number by 3 and subtract 1 from the product. Let's say that again. Multiply the part number by 3 and subtract from the product. So 1 times 3 is 3 minus 1 is 2. 2 times 3 is 6 minus 1 equals 5. 3 times 3 is 9 minus 1 equals 8. 4 times 3 is 12 minus 1 equals 11. So to answer for part 10, all she does is, let's say that we wrote 10 here. Let's write down with red. So now, let's open this up just a little bit more, just so we have some room. If I went all the way down to 10, what is 10 times 3? It's going to be 30, but it's always 1 less than the part number. So what is 30 minus 29? And the answer would be what? You're right. It's going to be 29. Well done, everyone. If you're confused by any of this, please feel free to go back to any part that was confusing. In this chapter or this lesson, you're going to be specifically looking at the table of values. I would appreciate if you were able to title it, just like how Mai did. Title it, have your columns organized, and use ruler lines. Please, please, please use ruler lines. It hurts my heart if you guys don't use ruler lines and it's all messy. Take your time. I want you to understand this rule of just how the columns are in relationship with each other. If you have any questions, feel free to let me know. All right, happy mathing.